Hello everyone, thanks for clicking and taking the time to watch this video. We are PUR-Ethanol, and we are on a mission to revolutionize the American fuel industry. A mission we hope you will help us bring to the next level. Specifically, we have created a biofuel production process that converts waste plastic into ethanol and other low-weight alcohols. The potential of this process is really vast, but in this video we just want to go over the broad strokes of our process and help you to see where we're headed and where we came from. Our main goal is to bring awareness to this process and show the world why it is so important. So just a quick overview. First, we'll give you some background on who we are and how we came up with the concept for this process. Then we'll talk about how the process works and how green fuel companies, and any fuel company in general, can benefit from this process. So, we met as chemical engineering students in college, where we were united by our passion for preserving and protecting the environment. What we really wanted to solve was the problems associated with biofuels, problems which were preventing them from becoming mainstream fuels. One big issue is that current production processes are too inefficient to be widely adopted, as they consume more energy than they produce. Another issue is that agricultural biomass, like corn and sugarcane, leads biofuel companies to step on the toes of our country's food industry, leading to greater competition and higher prices. At the same time, we were also very intrigued by how Brazil was the world's first sustainable biofuels economy. Specifically, they have a system which allows for the utilization of their agricultural biomass waste for biofuel production, allowing for biofuels to be widely produced and used in most of their everyday vehicles. Over the years, the US has tried similar approaches, but to no avail. Many industry professionals consider Brazil's success to be due to their natural abundance of arable land and cheap sugarcane waste. That's when we turn to an economic concept called Heckscher-Ohlin theory, which states that countries that have an abundance of a valuable resource would have a comparative advantage over others that do not have that abundance. So, just because the system works for Brazil doesn't necessarily mean it will work for the US. Rather, we as a country should be using a resource so abundant here in the US that there's practically zero competition for it. So, we got to thinking about what the US has an abundance of but doesn't really utilize for any purpose. That's when we realized that plastic waste perfectly fills the same roles. In 2015 alone, 300 million tons of plastic was produced, but only about 6% of that was recycled. As a result, waste continues to build up, but production only continues to rise each year. Plus, our country's current disposal methods, like pyrolyzing and landfilling, can be hazardous, not just for the environment, but also for nearby communities. Thus, our concept was born. The PUR-Ethanol process that we created converts waste plastics, specifically polyurethanes, into ethanol fuel. We were able to accomplish this with the cleanest possible conversion through much painstaking research and a good amount of trial and error. And the best part is that this process is completely sustainable, as it utilizes a cheap, non-competitive, and virtually unlimited feedstock. This not only creates greater incentive, but also diminishes the effects of plastic pollution. Additionally, the process does not require burning the plastic, which means no harmful plastic-related emissions to worry about. Over the course of our research, we conducted laboratory-scale experiments to prove our concept, and designed numerous commercial-scale simulations on Aspen Plus software, which allowed us to optimize conditions, increase efficiency, and estimate real-world costs and profits. As we stated previously, the main feedstock used in this process's current iteration are polyurethanes, including thermosetting types. For those of you who don't know, thermosets are plastics which are very difficult to melt back down once they have been formed into a certain configuration or shape. So this is really great that the process works on all polyurethanes indiscriminately. However, we have substantial evidence which proves that the process can be adapted to use other plastics, like polyesters as well. Additionally, the process requires significantly less energy than other waste-to-fuel processes, such as plasma-enhanced melting, which is another great incentive. And no companies stand to benefit from the PUR-Ethanol process like green fuel companies. This is mainly because the process can be integrated into existing fuel production processes, specifically because many of these companies already have most of the necessary process equipment and facilities, or they may already have access to waste plastics. This would lead to significantly lower startup costs and, by definition, lower risk. Speaking of risk, continued innovation offsets risk, especially in an industry as turbulent as this one. While green fuel companies may benefit more, the truth is that any fuel company can really benefit from this. For instance, whether the process has to be set up from scratch or only partially integrated, a company can make about $26 million in annual revenue per plant. So, if it was being used in 4 plants, that would be about $104 million with a payoff period of about 2.85 years or less. However, this is at a standard process feed rate of 100 kilomoles per hour. This feed rate can still be scaled up for greater profit or scaled down for pilot scale. Also, if this process was adopted by a company, that company would be the first to pioneer a totally new type of biofuel market that is completely untapped. On top of all of this, standard fuel companies can adapt the PUR-Ethanol process into a co-gasification type system, or one that is not completely dependent on the waste plastic feedstocks. Various options like this add a degree of versatility to the process, leaving a large amount of room to increase profitability. This versatility extends to process byproducts as well, which include syngas, a fuel production intermediate, carbon monoxide, carbon dioxide, methane, methanol, and tar, as well as some others which are unfortunately proprietary info right now. However, we would welcome the opportunity to share this information, as well as exactly how the process works, if we were to enter any serious negotiations. So that's it. Thank you very much for watching. We'd really love to hear from you, so feel free to message us on Twitter or tweet about some of the content. If you're serious about potentially bringing this process to the commercial level, as I said earlier, we'd be more than happy to discuss details with you. And also, if you're really just interested and care about our mission as much as we do, please share our mission on social media and tweet or retweet us. Again, we are PUR-Ethanol and we strive to generate big economic change, but we also realize that it can't be forced. It has to be done organically, through innovations which create value and work within the parameters of our country's economic structure. We are innovators, makers, and idealists, but above all, we are engineers, who believe that pragmatism and innovation are all that's needed to bring about strong and meaningful change. Thanks again for watching.